which is given just one function over entire time interval, whereas the radial motion, as you see, several functions we call piecewise functions can describe position over different time interval. Then using definition of instantaneous velocity, which is a derivative of position with respect to time t, and the graphical interpretation of a derivative is the slope of a tangent line. So we take a tangent on any point of a position curve and calculate the slope by taking derivative. Then we can construct a velocity that is instantaneous velocity profile like this. Then again, this velocity described by several different functions. Again, that is piecewise functions over different time interval. Then we take another derivative, which is instantaneous acceleration. So consistently, we can construct a velocity profile and acceleration profile for given position profile, or we can go backward. For given acceleration profile, by integrating, we can go back to a velocity profile and integrate the velocity again with respect to time t, which will give us position profile. Okay, let's take example. The VT graph for a particle moving through an electric field from one plate to another plate has the shape shown below. So velocity profile is given. And where t prime is 0.2 seconds, this is 0.2 seconds. T prime divided by 2, that is 0.1 seconds. As you see, at 0.1 seconds, we have a maximum velocity, which is 10 meters per second. Construct ST graph and AT graph for the particle. When time is 0.1 seconds, because t prime is 0.2 seconds, 0.2 divided by 2 is 0.1. The particle is at 0.5 meter. Okay, then we need to find a velocity function. This is piecewise function. Whatever, I want to find the equation for this velocity as a function of time t, time interval between 0 and 0.1 seconds. Also, you need to find function form, whatever, between 0.1 and 0.2 seconds. You need to find equation for this velocity. Let's call this one and that one. Okay, that is your work. Then you can construct ST graph. First, you need to find the function form for the velocity for the first time interval and a velocity form for the second interval. We see a linear. This is a linear. Okay, the velocity is a linear. I want to find this one by yourself. And after that, you can construct, once you find the velocity profile, and then by integrating, because the velocity is ds of dt. By integrating, you can find ST graph. For given a velocity graph, by taking derivative with respect to time t, you can construct AT graph. Okay, we're gonna do a breakout room activity again. So how many students? 13, so 3 rooms. Maybe forums? Forums, make forums. I'll give you 30 minutes. Okay, first room, Miguel, Preet, Skylar, Taylor. Second row, Ian, Jonathan, Max, Michael. Room 3, Blake, Jeremy, Tim. Room 4, wait a minute, George and Jackson. I'm gonna move Miguel to room 3, room 4. Okay, okay. First group, Preet, Skylar, Taylor. Second group, Ian, Jonathan, Max, Michael. Third group, Blake, Jeremy, Tim. Okay. Fourth group, Jackson, Miguel, George. All right. I'm gonna open all the rooms. You guys join outside the room and work together. First, you need to find the velocity function. You can write this way. First time interval velocity 100 t. T is in between 0 and 0.1. If you want to, you can put equal sign. That's okay. Doesn't matter. Second time interval, the velocity equals negative 100 t plus 20. Then acceleration first. That is straightforward. Acceleration derivative of velocity with respect to time t. Derivative of 100t with respect to time t, 100. Second time interval velocity was given negative 100t plus 20. Derivative of it, negative 100. Then we can construct acceleration curve. This is A. Don't forget the unit and right symbol and unit. Meter per second squared. In your tests, if you do not give the unit, I'm going to take points off. And 100. Horizontal line for the time. Seconds. Oh, sorry, T. T unit second. Use parentheses for the unit. Okay, then here is point 2. Point 2. First time interval between 0 and 0.1. Acceleration is 100. This is it. 100. Second time interval between 0.1, 0.2, negative 100. Negative 100. This is it. As I told you before, do not connect with the line or do not shade under acceleration. Here, there should be discontinuity like this. So this is it. Now then, ST graph. We notice the velocity is instantaneous velocity. That is derivative of position with respect to time t. First time interval between 0 and 0.1 seconds. ds over dt, that is 100t. Solve for ds. That equals 100t and dt. Integrate separately. 0 to S. Time 0 to anytime t. Then 1 is recognized. Antiderivative 1 respect to S is S. Plug in upper limit S, lower limit 0, then the left hand side S minus 0, that is S. Antiderivative 100t is 50t squared. Upper limit t, lower limit 0. So this is profile of position in the first time interval. Okay, then when time is 0.seconds, what is S? S of 0.1. 50 times 0.1 square, right? 0.1 squared is 0.01 times 50, that is 0.5 meter. See, look at that. It's perfectly matched, right? Okay. When time is 0.1 seconds, S is 0.5. Yes, perfectly matched. So now then, second time interval, t between 0.1 and 0.2 seconds, ds over dt equals negative 100t plus 20. Okay, then again, separate the variable and solve for ds. ds equals negative 100t plus 20 and dt. Integrate separately. Second time interval, time starts from 0.1 seconds to any second t. When time is 0.1 seconds, using this function of the position, we evaluate its position. So position starts 0.5 to any s. Okay, then evaluate the left-hand side. 1 is recognized. 1 antiderivative of 1 with respect to s is s. So left-hand side, s minus 0.5. Okay, that equals antiderivative of 100, negative 100t, that is negative 50t squared. Antiderivative of 20 respect to t is 20t. Then evaluate lower limit 0.1 and upper limit anytime t. You can evaluate this one. Okay. All right, then. Plug in upper limit. S equals upper limit t negative 50t squared plus 20t. And plug in 0.1 into t here and there. You can evaluate negative 50 times 0.1 squared, that is positive 0.5, plus 20 times 0.1, that is okay, let me see. Yeah. Plug in upper limit and lower limit. So this is negative 0.5 plus 20 times 0.1, that is what? 2. 2. Oh, sorry. That is 2. That is 2. Wait a minute, wait a minute. Let me see. Okay, here is it. We subtract negative, negative makes positive. Yes, zero point 0.5. And then negative 2. And then I brought left-hand side, the negative 0.5 to the right. That makes positive 0.5.
Professor, what's the symbol right in front of the -2? Is that a 0.5?
0.5. Yeah, plug in point 1 into t. That is 0.01 times negative 50. So negative 0.5, but we subtract the low limit. That's why positive turns out to be positive. Then we solve for s. So simplify. Here is 0.5, that makes 1. 1 minus 2, that is negative 1. So finally, position function s equals negative 50 t squared plus 20t n minus 1. This is final. In the second time interval. In the first time interval, s is this. Second time interval, s is negative 50t squared plus 20t minus 1. Now then we have graphed this one properly. Now I'm going to delete some of those. And the graph 50t squared and the negative 50t squared plus 20t minus 1. So I explained already a few times how to graph quadratic, right? Using vertex. Do you remember? 50t squared is straightforward. As you see, leading coefficient, that is highest power coefficient, is positive, then U shape opens up. Whereas if leading coefficient is negative, then still U shape, parabolic, but opens down. Keep that in mind. So in the first time interval, quadratic opens up. Okay, a little bit delay time, relay time for the iPad. Okay, then S. T for second. S meter. Okay, then this is positive, so open up U shape. Start from 0. When time is 0, then 0. Then when time is 0.1, 0.1 seconds, its position was 0.5. So this value is 0.5. Opens up U shape. So this is it, like this. What about this guy? S equals negative 50t squared plus 20t minus 1. Can you graph this one using the vertex? So you have to graph properly, otherwise you would not be able to get the full score. Also, don't forget the unit and boundary value. Boundary value is 0.5. Using second position function, you can calculate the position when time is 0.1 seconds. Plug in 0.1 second into the function. You're going to get, again, 0.5. Okay. Now then, the vertex T equals negative b over 2a. b is 20, so negative 20 over 2a. 2 times negative 50. So what is it then? 20 divided by 100. So point 0.2, positive point 0.2. Vertex is positive point 0.2. So then quadratic is symmetric with respect to vertex. Plug in point 0.2. When t is point 0.2, then evaluate s of point 0.2. Plug in point 0.2 into t and evaluate. Then I want you to calculate by yourself, okay? So whatever number comes up, probably somewhere, then leading coefficient is negative, so the U shape opens down. So it should be like this. And symmetric like this. However, time limit is 0.2, so we do not graph this part. Okay, so I want to evaluate this value. Okay, that is maximum. So simply plug in point into t into this function, then you can evaluate. This point we know that 0.5. So now then this function form negative 50t squared plus 20t and minus 1. What is this function? 50t squared. Okay, you can show the function form too. Does it make sense? Okay, so for the erratic motion, find function form for the different time interval. Probably your test, probably function form would be given, but otherwise from the graph, from the diagram, you need to find the function form. Okay? Question. Somebody left already? Then I would consider the absent. All right, let's move on. Couple more problems we're going to work on. And then the next week, you're going to take a test. I'll give you a whole week next week. I'm going to send the test tomorrow to our testing center. So what I want to check testing center hours. Can you see it? From Roan State Community College main web page in the search here, simply type testing center, then you can check hour. So let's take a look at that. Most of we will take Roan State, Roan County Testing Center. That is main campus Herman. Monday, no Monday, right? Tuesday, Wednesday, Thursday, Friday, Saturday. I want to finish, complete the first test by next Saturday. Okay? Some of you will go to Herman. Some of you will go to Oak Ridge. Oak Ridge, no Tuesday. All right. I want to check this down. You need to bring ID, right? ID, and also scratch papers and calculator. All right. Open notes. Remember open notes. Bring notes. All right, then let's continue. Okay, let's work on one more problem. curvilinear motion rectangular component, that is 3D motion. As you see, the position given in Cartesian vector form. Alt equals x of I, yj hat, zk hat. As particle moving along this curvilinear path, its xyz coordinate will change. So xyz coordinate would be the function of time t. Okay, then we take the derivative with respect to position function, in this case, position vector, which is instantaneous velocity vector. So x dot I hat, y dot j hat, z dot k hat. X dot is x component velocity. That is the same as vx. Vx is dx over dt, and so on. Direction of instant velocity is always tangent to the path. Take another derivative with respect to a velocity vector. Then we're going to have acceleration. All right. This problem, packs A and B are restricted to move in elliptical slots due to the motion of a slotted link. If the link moves with constant speed of 10 meters per second, 10 meters second to the right. Determine the magnitude of a velocity and acceleration of pack A when x equal 1 meter. Pack A is this. Here. Then path is given. Path function is this. X squared over 4 plus y squared equals 1. Now then we need to find what? A velocity at A. That is instantaneous velocity. Direction of instantaneous velocity tangent to the path. Okay, also we need to find the magnitude of acceleration. Now, x squared plus x squared divided by 4, that is equation for ellipse. All right. So we need to find the xy coordinate of pack A. Now, rearrange the equation. X coordinate of pack A is given 1 meter. So we need to solve for y. And then y squared equals 1 minus x squared over 4. All right, then. Y equals then plus minus square root of 1 minus x squared over 4. Okay, then when x equals 1, we solve for y. Y equals plus minus of square root of 1 minus 1 squared is 1 over 4. 1 minus quarter is 3/4. So plus minus square root of 3 over 4. Okay, then in decimal, that is plus minus 0.866. So peg A is x coordinate 1. So look at that. Y coordinate is positive 0.866. Peg B, x coordinate 1, y coordinate negative 0.866 meters. Now that we need to find the velocity at this point. Yes? Okay. And then velocity. Velocity x component is dx over dt. Whereas the velocity y component, dy over dt. This is already given. See? Moves with constant speed. This is 1 on 10. Already given. This is constant. We need to find this one. How? We need to take a derivative of y respect to t. Okay, y equals is this. We take a derivative of this one. Positive is the curve above. This is positive. 1 minus x squared over 4. Whereas negative is this. Function 4 is negative down below x-axis. Y equals negative square root of 1 minus x squared over 4. So now we take a derivative of y with respect to t. Then y is a function of x. So we're going to use the chain rule, right? But remember, because we have square roots, taking derivative, of course, we could do that using power rule, bring down power, lower power by 1. But it's not. So if y equals f of x, this kind of form, this is called explicit function. Whereas function form is like this. Multivariate function. In this function, we have x variable, y variable that equals constant. This function is called implicit function. We're going to use this function for the derivative because function format is given. 104 x squared plus y squared equals constant. This kind of format, right? Implicit function. Now, to find the velocity x component, the velocity y component, we take a derivative. Now, x is also a function of time t. Time t is embedded in x and y. Okay, then we're going to use chain rule. To find the velocity x component to y component, we take a derivative of this function with respect to time t. Right hand side, the derivative of 1 with respect to time t is obviously 0. Now, as I told you, in x, t is embedded in. So we take a chain rule. Take a derivative with respect to x first. 1 over 4. Derivative of x squared is 2x. And we use chain rule, right? This is a velocity x component. Plus second function, t is embedded in. First, take a derivative with respect to y. That is 2y. And dy over dt. That equals 0. Now then simplify. So 2 over 4, that is 1 over 2. X, I'm going to use dot notation, x dot. That is dx over dt. That is the velocity x component. Okay, so for okay. Now that is same as 1 over 2 x vx plus 2y vy. That equals 0. We need to evaluate this guy. Where? At A. velocity x component is constant because the Lincolns move with to the right with a constant speed. That is velocity x component. Now then, velocity x component we already know. Now we evaluate velocity y component when x is 1, y equal 0.866. That is xy coordinate of pec A. Okay, then at A, so we use implicit function format for the derivative. I want to remember that. We can evaluate the velocity y component. A, peg A, which means x equals 1, y equal 0.866. And then 1 over 2, x is 1, velocity x component is 10, plus 2 times y is 0.866, and velocity y component, that equals 0. That we solve for velocity y component. Turns out to be how much that would be. What is it? Where I calculate this one. Okay. Should be negative, right? Negative 2.887 meters per second. Okay. The magnitude. So x component is constant. Say, look at that. X component is constant. Y component negative, right? Okay. And then magnitude. The velocity at A, square root of velocity x component square plus velocity y component square. Then plug in x component is 10. Y component negative 2.887 make square. Turns out to be 10.4. Okay, this is it. So we take one more derivative to get an acceleration. Okay. So acceleration, x component obviously 0. Then we take derivative on this to get acceleration y component. Okay, we're going to do that the Thursday. Okay, so Thursday we finish this problem and next problem. And following week, you're going to take a test. All right, this is it. Any question? Any question?
You said we have till the 14th to take the test, right?
You check the date. I don't know the exact date.
Okay, I'll double check it. Thank you.
Yeah, by Saturday of next week, I believe. Yeah. So I don't know the exact date. Okay, I'm going to send you a test to each